Welcome everyone. Let's jump right into this explainer, shall we? Today, we're doing a bit of a post-mortem on quality control. We're going to look closely at the actual on-the-ground site mistakes that literally destroy buildings. Now, I really want to speak directly to the site engineers tuning in today, because look, concrete is an incredibly sensitive material. It's made right there on the site. Unlike factory-produced steel, where conditions are strictly controlled, concrete's ultimate strength is decided in the mud, the heat, and the pure chaos of a construction site. You know, there's this old foundational saying in concrete technology that hits the nail on the head. It goes, broken stone, sand, and cement make good concrete, but the exact same proportion also make bad concrete. Think about that. You, the engineer on site, you're the ultimate line of defense. Literally identical ingredients can lead to disastrously different structural outcomes, and it's based almost entirely on the human element. So, what does this all mean for how we view quality control? Well, it's definitely not just some theoretical concept you study in a textbook, it's an absolute survival mechanism. Quality control during the casting process is the literal difference between a building that stands for generations and a premature, catastrophic collapse. It's all about stopping those tiny, microscopic failures before they snowball into macroscopic disasters. To understand exactly how these failures happen, we're going to systematically dismantle the 6 deadly sins of site engineering. We'll be covering procurement, selection, mixing, placing, chemistry, and finally, post-casting. All right, let's get into it. Number 1. Procurement, the expiration trap. So, this first major mistake, it happens before a single drop of water is even added to the mix. 15 to 30%. That huge number represents the catastrophic strength loss that happens when engineers don't reject expired cement. The Indian standard, IS 269, is super strict about this. It specifies a 3-month shelf life from the bagging date. When cement just sits around for more than 3 months, especially in a humid warehouse, it completely loses its reactivity. You'll see small contractors sometimes buy this discounted old stock, right? And then boom, you get mysterious strength failures down the line. Always check those bagging dates. And honestly, just reject deliveries older than 60 days to be safe. Number 2, selection, the grade confusion. Okay, this next one is a really fundamental misunderstanding, and it plagues so many construction sites. Engineers constantly confuse the cement grade with the concrete grade. Let me be clear. Using OPC 53 cement does absolutely not mean your concrete is automatically going to be M53. The 53 in OPC refers strictly to the standard cement mortar strength at 28 days. M53, on the other hand, is your concrete mix design target. That depends on your water-to-cement ratio and your aggregate proportions. If you just throw OPC 53 into a standard nominal mix, you might only end up with M25 or M30 concrete. In practice, we all have this instinct that higher is better, right? Well, here, that instinct is actually super dangerous. For your general RCC work, stuff like M20 to M35, you really need to default to OPC 43 or PPC, which is Portland Pozzolana cement. If you use OPC 53 in massive concrete pours, like a thick raft foundation, its high heat of hydration is going to cause severe thermal cracking. It's a mess. You want to reserve OPC 53 exclusively for precast, pre-stressed, or really high-grade concrete where you actually need that rapid early strength. Number 3. Mixing, the excess water trap. Now this is probably the most universal site mistake of them all. During mixing, engineers are always caught between a rock and a hard place. Workers are demanding higher workability to make placing easier, and, well, the absolute easiest fix is just splashing in some extra water. But here's what happens. Without dispersing agents, the cement particles flocculate, meaning they clump together, and they trap that extra water inside. And that trapped water, it does absolutely nothing for hydration. It just sits there, creating voids, jacking up the concrete's permeability, and completely weakening the critical transition zone between the paste and aggregates. This source material actually uses this really unforgiving metaphor for this exact practice. Adding extra water just to artificially boost your slump? It's called an unengineering criminal act. It is literally described as sowing the seed of cancer in concrete. That single decision to add more water absolutely dictates the future degradation of the entire structure. No going back. Number 4. Placing, compaction, and vibration failures. All right, moving on to the actual physical act of placing the concrete. If you don't get 100% compaction, you're leaving lethal, continuous flaws right inside your structure. If you undervibrate, or if you're dropping concrete from way too high, you set off a disastrous chain reaction. Step 1. Entrapped air and bleeding water get left behind in the mix. Step 2, as that water tries to bleed upwards, it gets trapped right underneath the internal rebar and flat aggregates. This creates massive voids and basically destroys the bond. And step 3, those continuous bleeding channels make the concrete incredibly permeable, rolling out the red carpet for aggressive chemicals to just invade the structure.
Number 5. Chemistry. Ignoring invisible chlorides.
You know, it's scary, but the greatest threats to concrete are usually completely invisible to the naked eye. We absolutely have to enforce strict, hidden chemical limits. For instance, the IS 269 standard limits chlorides to just 0.1% by mass of cement. And if you're dealing with high-stress, pre-stress concrete, that limit drops to a razor-thin 0.06%. Why so strict? Because if you ignore these limits, the chlorides will literally strip away the highly alkaline, protective passivity layer that surrounds your steel reinforcement. Once that's gone, the steel rusts, it expands, and it literally blows the concrete apart from the inside out. To put that into perspective, globally, the corrosion of reinforcement causes a whopping 40% of all structural failures. Crazy, right? So, how do we actually fight this invisible enemy? Well, the Indian Standard 456 basically gives us the exact cheat code. By sticking to its mandated maximum free water-to-cement ratios and making sure you hit those minimum cement contents based on whatever environmental exposure you're dealing with, you create this dense, totally impermeable matrix that keeps all those aggressive, invisible chemicals safely locked on the outside where they belong.
Number 6. Post-casting, the crucial curing phase.
Okay, so this final mistake happens when engineers do everything right, they successfully pour the concrete, and then they just abandon it during its absolute most vulnerable state. The physical damage you see from this is plastic shrinkage cracks. When fresh, uncured concrete gets blasted by a hot sun and dry winds, the surface dries out way too fast. That leaves the top layer with poorly hydrated cement and a super weak gel structure. It just cannot handle the shrinkage stresses. So it cracks, it loses its abrasion resistance, and you've permanently crippled the durability of that element. The source material actually has another fantastic metaphor here. It compares delayed or interrupted curing to an ill-fed baby. Think about it. If you don't feed the hydration process with enough water during its absolute most critical growing phase, you permanently stunt the concrete's long-term strength. You can't fix it later. It just stays vulnerable to the elements for its entire, significantly shortened lifespan. Which really leaves us with one final, pretty heavy question. Is your concrete building a legacy or is it a liability? As we've seen today, skipping out on quality control, whether that's using expired cement, tossing in a splash of extra water because it's easier, under-vibrating, or just walking away and skipping the cure, it doesn't just compromise a single pour. It literally sows the seeds of building collapse. Uncompromising, strict quality control is the only way to ensure a structure actually stands the test of time. I really hope this explainer has given you the insight to maybe rethink some of your daily site habits and help us all build safer, stronger structures. Thanks so much for learning with me today.